China just pulled off something that sounds almost impossible. A crewed spacecraft launched, reached orbit, and docked with the Tiangong Space Station in only 3.5 hours, the fastest docking China has ever achieved. But speed wasn't the only surprise. On board with 3 astronauts were 4 tiny passengers, mice, the first mammals ever sent to the station to study life in space. This isn't just another routine flight. It's a precision-engineered leap proving how far and how fast China's space program is accelerating. 1. Breaking the speed barrier. 3.5 hours. That's all it took for the Shenzhou-21 spacecraft to go from launch pad to docking port, a record that stunned even seasoned space analysts. At 11:44 a.m. Eastern, 15:44 Universal Time Coordinated, a Long March 2F rocket roared off the Zhenzhou-21 Satellite Launch Center in China's Gobi Desert, carrying Commander Zhang Lu and crewmates Wu Fei and Zhang Hongzhang. By 3:22 p.m. Eastern, they were already attached to Tiangong's forward port, cutting the traditional 6-hour process nearly in half. How did China pull it off? Precision, orbital math, and automation. Every stage of the flight, from booster separation to orbital insertion, was pre-calculated to the millisecond. The spacecraft's onboard computer synchronized its orbit with Tiangong's trajectory, while ground radar and tracking stations executed near real-time course corrections. Unlike earlier missions that required several orbits to chase down the station, Shenzhou-21 nailed its rendezvous on the very first pass. This kind of accuracy doesn't happen overnight. It's the result of 3 decades of cumulative experience since China's first crewed flight in 2003. Each Shenzhou mission has refined the timing, software, and docking mechanisms until Tiangong now operates like a living machine, able to receive new visitors almost instantly. So why does it matter? In crewed spaceflight, time equals risk. The longer a crew spends free-flying before docking, the higher the stress on fuel, systems, and people. A 3.5-hour window means less consumption, less radiation exposure, and faster activation of life support modules once aboard. It's also a statement of maturity. China's space program has moved from "can we do this safely?" to "how efficiently can we do it every time?" Rapid response capability is essential not just for station logistics, but for future lunar missions, where narrow launch windows demand extreme timing precision. And symbolically, it projects confidence. While other nations scale down their low Earth orbit operations, China is accelerating. The Shenzhou-21's lightning-fast arrival sent a message. Tiangong isn't just operational, it's becoming routine. Now that the spacecraft and crew are safely aboard, the focus shifts from how fast they got there to what they brought with them. And that's where things get really interesting. 2. Science in orbit. Mice, genes, and materials. Inside the lab modules of Tiangong, the Shenzhou-21 crew began unpacking a small biological payload that could redefine China's space research. For black mice, 2 males and 2 females. It's the first time China has flown mammals to its space station, marking a milestone in life science experimentation. Why mice? Because they're miniature models of us. Their physiology reacts to radiation, stress, and gravity shifts in ways remarkably similar to human biology. Studying them in orbit helps researchers predict how long-term microgravity affects everything from muscle loss and bone density to reproduction and behavior. According to the China Manned Space Agency, this particular experiment aims to observe how confinement and microgravity influence the rodents' behavioral patterns and internal systems. Over several days, cameras and sensors will track the mice's motion, feeding, and rest cycles, while biomedical monitors record heart rate and metabolism. When they return to Earth, scientists will dissect tissues to analyze organ changes caused by the space environment. But that's just one piece of the science puzzle. The crew will perform 27 experiments spanning biotechnology, materials science, fluid physics, and space medicine. Among them, genetic chirality research, exploring how amino acids behave differently in space to test theories about the origin of life. In situ testing of lithium-ion batteries under cosmic radiation and microgravity, crucial for future spacecraft energy systems. Combustion and material synthesis studies, examining how flames, fluids, and alloys behave without gravity-driven convection. Information vital for developing space manufacturing techniques. Each project links directly to long-term human habitation goals. For instance, understanding microgravity's effect on mammal reproduction is key for future lunar or Martian outposts. Likewise, testing power systems and materials in orbit provides design data for hardware that must survive far harsher environments. This shift in focus, from engineering achievements to biological and applied research, marks a new phase of Tiangong's mission. China is no longer proving it can put people in orbit. It's using that orbit to conduct serious science that feeds into every layer of its future exploration plans. And if you think a few mice in space are impressive, wait until you see how these results tie directly into China's biggest goal yet, sending humans to the moon. 3. From Tiangong to the moon. To understand why Shenzhou-21 matters so much, you have to see it as part of a bigger roadmap, one leading straight to the lunar surface. Before launch, the China Manned Space Engineering Office, CMSEO, gave rare updates on its crewed moon program, confirming that several critical systems have finished their prototype stage. These include the Long March 10th heavy lift rocket, the Mengzhou Deep Space Crew Capsule, the Lanhua Lunar Lander, the Wangyu spacesuit, and a lunar rover designed for short-range crew mobility. The first test flight of Mengzhou and Long March 10th is expected around 2026, paving the way for an actual moon landing before 2030. So where does Shenzhou-21 fit in? Tiangong is the rehearsal stage. Every experiment in life support, every extravehicular activity, every day spent maintaining systems in orbit builds the human and technical endurance needed for lunar operations. The new record-fast docking isn't just for bragging rights. It demonstrates that China can handle time-critical maneuvers, a vital skill for moon missions where every orbit counts. Even the mouse experiment plays into this long-term vision. Understanding how mammals cope with stress, confinement, and microgravity helps scientists design health and reproduction protocols for astronauts who may one day spend weeks on the lunar surface or in orbit around it. Shenzhou-21 also showcases a generational shift in China's astronaut corps. Wu Fei, only 32, is the youngest taikonaut ever to reach orbit. Evidence that China is training crews not just for station duty, but for deep space exploration. The mission structure, with a pilot, engineer, and payload specialist, mirrors the kind of multidisciplinary teams needed for lunar operations. Add to this the consistency of Tiangong operations, permanent occupation since 2022, overlapping crews for smooth handovers, and flawless logistics supported by Tianzhou cargo ships. It's clear that China's model now resembles NASA's post-Apollo Skylab era. Except this time, the station is not a stepping stone after the moon, but a platform before it. When you connect all these dots, the speed, the science, and the station's growing reliability, the picture becomes clear. Shenzhou-21 is less about today's mission and more about tomorrow's destination. In just 3.5 hours, China showed the world what coordinated precision looks like in spaceflight, and in 6 months, its astronauts will turn that precision into discovery. Shenzhou-21 isn't just a mission, it's a statement. A statement that China's space program has entered a new era where every launch contributes to a much larger dream: to sustain life beyond Earth and, soon, to walk on the moon. The 3 astronauts and their 4 small companions may orbit only a few hundred kilometers above us, but their work reaches far further, into the science of life, the mastery of space, and the future of human exploration. If you enjoyed this video, please like, share, and subscribe for more space updates. Your support means the world and keeps our journey going.